Okay.
Now, just go like this.
What we're doing today, we're going to look at the expected value or the mean and the variance of discrete random variable. All right. So the main thing for you to know for today, you should be able to calculate the mean or the expected variable of a discrete random variable given the probability distribution or the PMF. All right. You should understand that the mean can be defined as a long-term expected value and use this to interpret. Use this interpretation of mean to solve problems involving discrete random variables. You should be able to calculate the variance and standard deviation of a discrete random variable given the probability distribution or the PMF. You should be able to derive a relationship between the expected value and variance and be able to interpret the variance and standard deviation in practical context. All right? Now, so if you think about a situation, we have probably the experiment involving the tossing of a regular unbiased coin 3 times. And if we define x as the discrete random variable representing the number of heads they're obtaining in 3 toss, so we're thinking about the number of heads only. All right, could be 3 heads, 2 heads, 1 head, or 0 head. The question is, what is the most likely number of heads we would expect to obtain in 3 tosses of the coin? All right, so the word most likely. Let's think about the word most likely. So in the context of statistics, when we started learning statistics, most likely value links back to the measure of center. The measure of center is the mean, median, or mode. All right? So now in the context of random variables, we're actually considering the most likely value as the expected value. All right? We call it the expected value of the random variables. Now, so the expected value or the mean of a random variable with the probability of x equals to x is the weighted average of each of the outcomes. So you must know the word weighted. We are using the weighted average of each of the outcomes of the distribution, whereby the weight of each outcome is corresponding value of the probability of x. And this is the reason why it's often referred to as a random variable. Now, the expected value of the DRV, this is the equation you use, which is x, which is the observed value, times the probability of x1, x2 times the probability of x2, and so on and so forth, and until you go to xn, the nth value of x times the probability of xn, and you sum them all out, and that's the notation. Looks complicated, but it's pretty straightforward. All right? The reason why I say it's pretty straightforward is, let's do it on the table. So if you've got a table like this, you've got your table, I'm giving the table to you. You should be able to work out the mean of x, or the expected value of x. What you need to do is, with this table, you extend a row where you've got x times probability of x. So x is this, x times probability of px, which will give you that values. All right, keep doing that. Fill the table, please, and then sum it up, and that will be the expected value of the x, or find the mean. All right. So the first one, 0.25 times 0 is just 0. Then 0.3, 0.4, and 0.75. So the expected value is the sum of x times px. All right? Sum of all this and reaches 1.45.
So difficult.
And find probability of x less than mu. Alright, you could use the mu to represent EX, expected value of x. So you could either use EX or mu. So less than mu, which is less than 1, because this is a discrete random variable, although the expected value is 1.45, less than or equals to mu, therefore it's less than or equals to 1.
So you got to round it down.
0.1.
You got to round it to the nearest whole number.
Yeah, round it to the nearest whole number. Whether it's greater than or less than. So it's less than, you round it to the nearest whole number, which is 1. If it is greater than or equals to, you round it up to 2. Yeah? So look at what that symbol is. Yeah? It's discrete. It's not continuous. Alright? So therefore that's 0.25 plus 0.3, which is 0.55. Alright, the sum of the probability. Those two. We are looking at the probability. And the expected value is somewhere here. It's discrete, so you have to round it down or round it up. Depends on where the symbol is.
Wait, so if it's greater then you go to
2.
2. Oh, okay.
Greater than or equals, you go to 2.
Yeah.
But if greater than, you have to go back to 1. Cannot be 2.
Okay. Yeah.
Sorry, greater than, sorry. If it is greater, sorry.
1.5.
If it's greater than or greater than or equals to mu, which is 1.45, so it has to be 2.
Okay. Yeah.
Right?
Yep.
Yep. Got it? Now, let's try example 2. The probability distribution of discrete random variable x is shown below. The mean of the random variable is 2.4. You need to determine the value of a and b. So you know the expected value already. You have to work out what a and b is. 2 pieces of information there. You know that this is the probability distribution. You should be able to realize that the sum of these 4 will give you 1, because the sum of the probability is 1. And then you know the expected variable, the expected value of x is 2.4, so you have to use 1 times a plus 2 times 0.1 plus 3 times 0.2 plus 4 times b equals to 2.4. Then you've got 2 simultaneous equations, and you can solve that. So 2 information. 1 you've learned from yesterday, 1 you've just learned it today.
So you get a 0.4, b 0.3.
Yeah.
Yeah. So that's 1. A plus b plus 0.1 plus 0.2 equals to 1. So therefore you know you have the first equation.
So the mean of a random variable is the expected value.
Yep.
Okay.
It's the same.
Yeah.
Mean and the expected value, they are the same thing. In this case. Alright? So it's 1 times a plus 2 times 0.1 is 0.2, 3 times 0.2 is 0.6, and 4b equals to 2.4. And then you've got another equation. You should be able to solve it. Either use substitution method or elimination method. This case is a little bit easier using elimination. Or use your calculator if it is calculator assumed. Question like this will not be calculator assumed, will be calculator 3, I would say. And therefore, you can work out B and A. Happy with that? Yeah. Alright, so that is the expected value or the mean. Now, what about the mode and the median?
Useless.
What? So,
There's no
you know that B is, A is 0. B is 0.3. hang on, A is 0.4. This is 0.3. What do you think the mode would be?
0.4.
No, that will.
Because
They're all the
if you draw the
same.
histogram, right, it's like the most, right?
0.4, that's a probability. So the mode is actually 1.
Right.
Correct? Because if you've got 10 values of that, 4 of them will be 1. 1 of them will be 2. 3 of them, 2 of them will be 3. And 3 of them will be 4. So you can think about, we don't use it that much, but mode is actually the outcome with the greatest probability or the greatest relative frequency. We'll use relative frequency a little bit later. Alright, so you've got to think about the greatest probability. And the median is the outcome which has a probability of 0.5 on either side of it. Alright, so K, that value of K has to be 0. The probability less than that has to be 0.5. The probability above that has to be 0.5. Not that I've seen a lot of questions like that, but it's information that you need to know, that's all.
Okay.
Alright? Now let's go to variance and standard deviation.
Classic.
So what we look at, the measure of center, only provide one way of describing your data. So recall describing your data in year 10 and year 9. So one of the things that we look at is mean, median, and mode. Now the next thing you need to look at is variance or the standard deviation. That's a measure of spread. Alright, how spread out the data is. This is a discrete random variable. Alright, we'll learn a lot more about standard deviation in terms of the bell-shaped curve in second semester. Alright, let's think about the variance of a discrete random variable. It actually measures the spread of the variable about the mean. Alright, how spread out it is. More specifically, it is a weighted average of the square deviation from the mean. So deviation from the mean is how much it differs from the mean. Alright? The reason you use variance is you try to avoid using negative number, you're squaring it. That's all. Alright? So, now the value of a DRV or variance of x or sigma square. Sigma square. Alright? It's the description and the formula looks complicated, but in fact it's not that bad. It's actually calculating the distance between each outcome and the expected value x minus mean. So let's say this is the expected value right in the middle. Alright, so use that example 1.45 just now. And you got 1, you got 0, you got 2, you got 3. Alright, so what you need to do, these are x. This is x, this is ex. Alright, you are just working out that distance. That distance, that distance, and that distance. Alright, how far it is away from the expected value. Now it could be positive, it could be negative, because you're using x to take away mu. Alright, you're using x to take away mu. So if this is 1 minus 1.45, you've got negative 0.45. Correct? That will be negative 1.45. This will be 0.55. This will be 1.55. Yeah?
Yeah.
So, in order to avoid working with the negative values, these are squared. Alright? So you have the variance, which is x minus mu squared times the probability of x. Again, it looks complicated, but if you use it in a table format, it will make life a little bit easier. I'll show you step by step. Alright? The units of the variance are the square units of x. Remember that.
So why do you times it by with the probability of x?
Don't know. You times it by the probability of x is because you're looking at, you have to use the weighted probability, alright? when you are actually doing the variance, you don't have, if you look at the standard distribution, you don't actually look at the probability. This time you have to look at the probability, how much is occur. So therefore, you need to multiply it by the probability. It's the weighted. Alright, you need to think about weighted. Now, standard deviation of DRV as dx or sigma is just taking the square root of the variance. Alright? So this is just a square root of variance x, that's it. So once you can work out the variance, you can work out what the standard deviation is. Alright? That, taking the square root, give you sigma. And the units of standard deviation are the same as the units of x.
So,
yeah.
What does like the variance tell you about the distribution in comparison to the standard deviation?
It's actually the same because variance is just a square of the standard deviation.
Oh, true. Yeah.
That's all.
Okay.
It is the same. All right. Now let's have a look at example 3. Consider the probability is mass function. How are you going to determine the expected value, the variance and the standard deviation? So the expected value, you should be able to do it straightforward. Is x times px and sum it up. So with discrete random variable, you always have to think about the probability because it's the weighted average thing. All right? You need to think about the weight of the how often it occurs, which is the probability.
Yep.
So you should be able to work that out. And then sum it up, which is 1.7. So you can see that the expected value is somewhere here. All right? Look at the weight. So you've got 0.5% that it will do a sanity check. Looking at just the data, it is actually weighted around here. See, there's a 0.4 of 0, 0.1 of 1, and then the rest 0.1, 0.2, 0.2. Sometimes you have to do a sanity check and see where it would land. If you work out a value like 3.7, you know that it's not correct because it should be somewhere around here. Sometimes you need to do a sanity check, look at the data. Alright? Now, here, the next thing you could do, again, draw it as a table. So you could work out x minus mu. You know what the mu is, right? What is the expected value? You know what the expected value is, which is 1.7. So the expected value is 1.7 in this case. All right? Work out x minus mu. 0 minus 1.7. Oh, and the next one is x minus mu squared. So you work that out. 1 minus 1.7. From there, you can square it. This is 1.7 minus 1.7 all squared. Alright, you can do that. Yeah, that's 2.98. Use your calculator in that situation. If you want to.
I can tell you.
Also, if you keep going, you should be able to work that out.
I'll have to look at it later.
Now, the next bit, you need to be able to work out what the variance is. The variance is therefore, again, you think about how far it is away from the estimated value, you've got to multiply it by the weight. Alright, the weight is very important in this case. So here, this bit here is 2.98. Oops. Hang on, what am I doing? 2.98. What am I doing? So 2. Sorry. So 2.98 times 0.4, 0.49 times
So what actually is the variance?
sorry?
What actually is the variance?
Variance is the distance from the expected value squared, that's all. You need to think about the distance from the
The weighted difference. The weighted distance.
What is that supposed to mean?
Because you're timing it by the probability.
Yeah, but how does it help you?
Yeah,
But so what
that,
is
that's the problem with high school.
So what if
she teaches?
Yeah, they don't show you how it tilts. Yeah.
So what does variance
do it
actually
like
tell you? Why do we need to
how far the spread is, how far it is away from the mean. So think about what the spread is.
Hopefully, Mr. Alphonse can teach us.
Probably.
You'll need to discuss.
Yeah, definitely.
Alright, so think about it is how the variance is actually how far this is from the mean, that's all. And you can work that out, 2.89 times 0.4 and so on and so forth. And finally, the standard deviation is the square root of 2.61, that's all. To 3 decimal places. You don't, in this case, because you don't have to go all the way up to the variance, for example, you don't have to go all the way up to 4 decimal places. Yeah, it just automatically comes to 2 decimal places for this question. Alright? Now, there's another alternative way of calculating variance, which is you can use the expected value of x squared, take away expected value of x all squared. Alright? So you could do it that way. You already worked out the expected value. Sometimes it is a little bit easier to use this, where you can work out x squared and then work out the expected value of x squared. And use one, take away the other, you still get the same answer. So write this down. I don't think this is in your formula sheet. It's just measure how far it is away from this as all. If you want to think about it, but this is not whatever you call it, this is not a normal distribution. Normal distribution, the variance measure whether it's how flat it is or how close it is. That's all. Alright? It's not the normal distribution. This is just using that as an example to show you how far away and how spread out it is. That's it. Alright? Alright. This one is another way of doing it. You've got it in front of you. You don't have to write everything down. Make sure that you have this. Highlight that. That's important. Sometimes it is a quicker way of doing it. Alright. Now let's use your class pad, please. Can you grab a class pad? So I would like all of you to get your class pad out and use the statistic mode of your class pad. Anyone without a class pad? Anyone without a class pad? Oh, no class pad. That is not maths. That's not maths. This is not maths.
Is that economics?
I have no idea.
So easy.
You got to use your own.
Gives
I want you to use a class back by yourself so that you can do it by yourself. No way are you going to. Alright? Now, what you need to do is. Alright. Listen, it really doesn't matter if you put x as least 1 or x as least 2. It's just that be consistent. Use x as least 1 and the probability as least 2. Just make sure that you're consistent, that's all. Alright? Just make sure you're consistent. Make sure that as soon as you get in the list, now especially for people who are doing both apps and methods, you'll be doing a lot of statistics using this bit. When you start doing this work, just make sure that you clear everything, alright? So into list 1 and list 2, and then you go to click calc 1 variable. So what you have is then x list is list 1, change the frequency list to list 2, alright? So that will give you your frequency, that bit here, and this will give you the x list 1. And you will come up with x bar, sigma x squared, and sigma x. Sigma x is your standard deviation. Alright? Sigma x is your standard deviation. You need to square it to get your variance. So in your class back, it doesn't give you the variance, it gives you the standard deviation. It gives you the standard deviation. So use your class back, you should be able to get x bar, which is the expected value of x, and SD of x, which is sigma x, standard. Then calculate the variation of x by just squaring sigma x. That's all. So use your class back, you must know how to use this. Rather than going and work out this using a table, use your class back if it is calculated assume section. Alright, everybody happy with this?
Yep.
Yeah?
Yeah.
Okay, let's do example 5. Example 5 is probably a difficult one in a way because you really have to know what everything is. So you've got 3 discrete random variable x, 3 outcomes only, p, q, and phi. So the probability mass function for x is such that p equals to x equals to, probability of x equals to p equals to 0.1. Probability of x equals to 5 equals to 0.3, and probability of x equals to q equals to 0.6. Now you also know the expected value is 7.1 and the variation is 6.09. You need to determine the value of outcomes of p and q. First thing I will do, I will draw a table. So I know x is p, 5 and q. I know the probability of x, 0.1, 0.33, 0.6. From there, I know that I can use my x times probability of x, sum of that to work out your expected value of x. So that times that, that times that, that times that, add up will give you 7.1. Then you need to think about the variance of x. How do you work out the variance of x? How do you work out the variance of x? First one, you use expected value of x, 7.1. So recall what you do with your variance of x. You need to work out
0.3 times 5,
the
1.5.
mu first. And then x minus mu squared times probability of x. So you know the expected value is 7.1 this time. because there are only 3 numbers here, I didn't actually bother writing down doing more of the rows. What I did was, straight away, I just wrote down probability of P times P minus mu, 7.1 square, plus 0.3, 5.7.1 square, plus 0.6, Q minus 7.1 square equals 6.09. Now, you will be using class pad excuse me, to solve this. So I'll show you what to do. Now this one, don't worry about expanding it. I'll show you what to do with your class pad. Alright, let's go to your class pad. Don't worry about actually simplifying that. In your class pad is capable of, if you put all this in. Alright, so under your class pad, in main, I'll go to clear everything first. Always clear your class pad, clear all variables for start of a new question. Go to keyboard and go to Maths 1, this one to solve simultaneous equation. Solving simultaneous equation, I'm going to use X to represent P, Y to represent Q. So 0.1 X plus 0.6 Y equals to 5.6. Alright, that's one. Now here, you can just type in 0.1 times X minus 7.1 square.
Isn't it 5?
Alright?
Oh, yeah.
Then the next one is, next one is 0.3 times 5 minus 7.1 all square plus 0.6 times Y minus 7.1 all square equals to 6.09. Alright? Make sure that you indicate to class pad you want to solve both X and Y. And then when you click execute, it automatically solves it for you. So you've got a few values. Could be P could be 2, Q could be 9, or P could be 14, Q could be 7. Alright? 2 solutions, 2 possible solutions here. So use your class pad wisely. Don't worry about expanding everything out. In this situation, you can just input all this into class pad. And you should get your 2 possible solutions. 2 and 9, P is 2, Q is 9, or P is 14, Q is 7. Alright? Alright, I'm going to stop here. And you should have enough questions, exercises